Hi everyone, today we are going to discuss number system. What is a number system? You should know this, and the types of number system, and the conversions of number system, and then we'll have the practice questions. First of all, number system is a way of writing or expressing numbers. It is a mathematical notation for representing numbers of a given set. You can represent a number using digit or a symbol. For example, 1, 1. This is in binary form it is 3, whereas in decimal symbol it is 11. So the same 1, 1 has two different meanings in different types of number system. Next is, these are the four types of number system: binary, octal, decimal, hexadecimal number system. We'll discuss each one of them one by one. First is binary number system. Binary number system, as the name suggests, bi means 2. So it has only two digits, 0 and 1. Every number value represents with 0 and 1 in this number system. The base of binary number system is 2 because only two digits are used to represent binary number system. Next is octal. Octal has a base 8 because 8 digits are used from 0 to 7. So it has a base 8. Next is decimal number system. This is the number system which we use in our daily life. It has only 10 digits, that is 0 to 9, and the base is 10. Base represents the number of digits in that particular number system. Next type of number system is hexadecimal number system. Hexadecimal number system is from 0 to 9, and then after 9, from 10 we represented it in alphabets, that is A, B, C, D, E, F. A is for 10, B to 11, C 12, D 13, E 14, F 15. So the base is 16 for hexadecimal number system. Next we have the summary table where all the four types of binary number system are given. All the number system are given: binary, octal, decimal, hexadecimal, and their corresponding base is given. For binary it is 2, the digits used 0 and 1, and the example is also given. This is how we write, with the brackets, and we write a subscript here, the base. Then is octal with the base 8, digits 0 to 7. This is example. Next, decimal with the base 10, 0 to 9 with an example. Next, hexadecimal with the base 16, 0 to 9. And then after 9, A, B, C, D, E, F till 15, that is 0 to 15. This is how we represent in hexadecimal number system. Next is the conversion of decimal number system to other base. The other base can be any base, that is, it can be binary, it can be octal, it can be hexadecimal. So there are two steps to convert a decimal number system into any other base. The first step is divide the number by the base of target base system, that is, and I'll give an example. This is how 1, 2, 3, 4, 5 is the given decimal number system. Divide by 2, you write the quotient here and the remainder here. So when you write this quotient here and remainder here, the final solution will be from bottom to top, that is MSB to LSB. MSB stands for most significant bit and LSB stands for least significant bit. So this is how you are going to divide. 1, 2, 3, 4 divide by 2. We divide by 2 because we are converting into binary and the base of binary is 2. When you divide by 2 here, the quotient is 6172 and the remainder is 1. 6172 divided by 2, the quotient here, the remainder here quotient here, remainder here, this way, and the answer will be from bottom to top. This is how you are going to write it in the binary form. So this is a conversion, is an example for decimal to binary. In the next example, we'll convert the same decimal number to octal to make it more clear. 1, 2, 3, 4, 5. Now we are going to divide it by 8 because we have to convert it into octal, and the base of octal is 8. We'll divide it in the same manner, quotient here, remainder here, and the result will be from bottom to top, MSB to LSB. Next is decimal to hexadecimal. Hexadecimal, the same way, now we are going to divide it by 16, and then the answer is 3039. Next example for the same decimal to hexadecimal is 725 divided by 16. Now in this case, we get the remainder 13, right? When you get the remainder 13, then you are going to use D for it. You will not write 13, you are going to use D for it. So the answer is 2D5. We'll use the brackets and then write 16 base, right? This is how you'll convert decimal to any other base. So I'll just recap. This is the same example for decimal to binary, decimal to octal, decimal to hexadecimal. The next is other base system to decimal number system. So now this is vice versa. You'll have any other base and convert it into decimal number system. So I'll give you an example. This is a binary number which we are given, and you have to convert this binary number into decimal. So first of all, you are going to write it in this manner, and below this you are going to write starting from 0, 0, 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13. Now I'll tell you how is this written. Digit, this is the above digit, multiply by the base because it's given in binary. So you'll take the base 2 and then the power. So 1 into 2 to the power 0, that is 1. Now this is the digit into base, and the power of the base will be 1. Same way you'll move from right to left, covering all the digits. Like see here, it's 10, so it's 0, 0, this digit, multiply 2 to the power 10, and you will get the answer 0. After doing this, add all these values and you will get 1, 2, 3, 4, 5 as your answer. So this is how you convert binary to decimal system. Okay, next is octal to decimal. For octal to decimal, you'll have the same pattern. In this case, it is now, you'll not use the part 2, you'll not use the base 2, you'll use the base as 8 because it's octal. So 8 to the power 0 into 1, then 7 into 8, 7 into 8 to the power 1. Same way you're going to do this and add these values and you will get the answer, right? 1, 2, 3, 4, 5. Previously we converted this same example to octal. Now this is vice versa. Next we have hexadecimal to decimal. So 2D5 we'll write like this, 2D5, and 0, 1, 2 will always move from right to left, So 16 to the power 0 into 5 plus 16 to the power 1 into 13. Make sure you use this 13 as a single digit here. Please do not split 1 and 3. It is used as 13, not 1 and 3. Please don't split it. Next is 16 to the power 2 into 2. This is how you get it, and then you'll add it, that is 725. Right. So let me summarize it now. What we have done with all the examples. This is an example of binary to decimal. This is octal to decimal. Next is hexadecimal to decimal. Now, these are the steps. Whatever I have explained you, this is an explanation regarding the examples which I have explained you. And now we have practice questions. So let us discuss this practice questions. First is convert this 10101 binary to decimal. So this is binary to decimal. I have already explained you any base to decimal. How do you convert any base to decimal? Next is 29 decimal to binary. That means 29 is in the decimal and you have to convert it into binary. How will you do it? You will divide it by 2 and then write the quotient and remainder on the right hand side and then move from MSB to LSB. For the third, 21 is given in the decimal form and you have to convert it into the octal form. For this, you have to convert first the decimal into binary and then binary to octal, right? The fourth is binary to hexadecimal. For fourth, you will convert first binary to decimal and then decimal to hexadecimal. Before we move on to the next slide, please solve these questions and the answers are given on the next slide. You can check them. These are the answers of the previous questions given. Next, I have given you this is a link for the online test of number system. When you read these slides, after that revise them and do click on this link for the online test to test your knowledge on number system, how much you have understood. Thank you.